All right, welcome everyone again to another episode of Looking Ahead, where we discuss everything cloud computing, AI, and how can we use machine learning to accelerate our software development lifecycle in general. Today, I'm going to have with me Mohamed El-Geish. Mohamed is a friend and also an entrepreneur, architect. He had a very interesting experience to share with us today. Mohamed actually right now works as a director of engineering at Cisco. And Mohamed has an interesting experience also before joining Cisco as a co-founder and also the lead architect at Voicea. With that, I leave it to you, Mohamed, to talk more about your experience in general. Welcome to the show.
Thank you.
And I'm excited to hear about your experience and everything AI and software development. So tell us more about your experience, how you ended up in Cisco.
Okay, I'm gonna start with kind of contact center versus data center, because I used to say the same thing, because I came from a background where we work a lot with data centers at Microsoft, and your brain always leans on the thing that you know most, right? So right now I'm director of AI for the contact center solutions at Cisco. I came to Cisco via an acquisition of the company I co-founded, Voicea. Voicea was an AI company capturing meeting notes and basically turning talk into action. So taking what you say, like in a call like this one, coming up with the follow-ups, action items, whatever you want to, come out with the meeting, outcomes and things that you want to follow up on, and push them to your enterprise software kind of, if you may call it source of truth or system of record, and have that acted upon sometimes during the call. So you can say something like schedule a call with Mohamed afterwards, or take a note or take an action item, and it happens right there and then. Before Voicea, I was managing a team at LinkedIn of AI personalization and recommendation for the news feed. So when you log into LinkedIn, you see recommendations, and we built the infrastructure for that as well. It was powering, the experience for multiple experiences, not just one news feed. You can see it in multiple places within the LinkedIn products. Before LinkedIn, I was at Microsoft. I worked on multiple products and services, namely anti-spam, email delivery. Before that, a lot of data centers, optimization, kind of repair, monitoring, deployments, tracking, and basically helping developers manage this very complex lifecycle of the software once they put something in the source control. What happens to the packages, the binaries, deployments, what happens after they deploy, taking care of the software logical and physical state. So you have a desired state and you want to enforce that. Sounds very familiar to you. And basically the idea, is to save them money and effort and time, in also encapsulating away all of these details for them to focus on the application logic. Before that, I worked on multiple products of Microsoft, the Visual Studio, and so on. At another venue, I also do part-time teaching assistant at Stanford for a deep learning class with Andrew Ng, CS230, and CS229, which is the machine learning class.
Nice. And you're also an author, a book author, right? Your book, Computing with Data, this is just released, I guess, a year ago, right?
That's more like, it feels like longer than that, but yes, more or less. Yeah.
Cool. All right. So it sounds great. So today, actually, I would like you to share with us your experience as an architect, as a software engineer, and also as someone who used machine learning to solve one of the most challenging problems. Machine learning has been used so far in a lot of problems that I would say that are not necessarily all the time related to software development, but you also have lots and lots of experiences, as a software engineer, as an architect, and maybe at certain points you would say, well, maybe that's a problem that machine learning can solve. And also you have a lot of experience about machine learning. So, hopefully we get some interesting thoughts and discussions today. So let's start with this. Let's start with your general experience as an architect and as a software engineer. You've been building and running software on the cloud for a long time now. Uh, what's your point of view on the state of the cloud and software development on top of the cloud? Do you see any challenges there? Do you see any bottlenecks that we're heading towards, or maybe that we're experiencing right now that worth sharing with others? And maybe we'll take this as a segue, talking about how machine learning can be used there.
Sure. So I think one of the biggest challenges is understanding the business, because we build software to serve some goal, right? At the end of the day, we don't just like write software in a vacuum for the sake of having software living and breathing somewhere. The idea is understanding where the business is headed and like what are the major outcome, like, or KPIs, the things that you want to really keep track of, and how can you translate that into requirements and basically desired state in your software, right? So think of like maybe something that is easy, like, or easier, relatively easier to like develop, maybe some application just for fun, maybe a project you came up with at school or something like that. The risk is really low, and you don't have the same challenges of like billions of users going in and like using your software. But as the stakes are increase, or the level of like adoption increases, uh, the challenges that you have to like overcome become more complex. And I emphasize on the word complex here instead of like complicated, because it's harder to like understand and harder to like solve, even if you have seen it before. It's maybe like some nuance and the subtlety like between complications and like complex or a complicated system and a complex system. I would say like a complicated system is something that you might have a pattern. Once you figure it out, they can actually reapply, and that's awesome because you could just like get somebody who's more experienced and figure out like, okay, you've seen this before, how can we solve it for this time as well? But a complex system is kind of unique, and you have to understand like there's always going to be a lot of trade-offs, and you have to translate these trade-offs into like processes and requirements, and eventually like code where the bits meet the metal. So a lot of times you look at like what are the business priorities. I had a great mentor and manager at Microsoft. Whenever he's faced with a decision, whether it's like code review or design review, the question that usually pops up in these kind of meetings he would ask is, what's the business impact? That's a good question. I think everybody should be asking when they think about like, okay, which framework should I use? Which system should I develop first? Like all of these questions, you have to have a strong alignment with the business requirements. So I think, besides that, let's assume everybody has understood, fully groped and understood the mapping between the system objectives and the business objectives, and they came up with like very clear alignment. Then it becomes about implementation, taking that like the scale we see of like big companies, like billions or hundreds of millions of users, for great applications like those, a lot of things could go wrong. The more integration points you have, the higher risk of things failing and breaking. And just the more people are involved, or the more engineers you have on the team, the dissemination of information, coordination between them also becomes a challenge. So all of these problems, whether it's like alignment with the business, implementation of such alignments, and mapping of these requirements, or just the idea that you have basically a huge group that you need to coordinate with, and you have to like have everything more or less goes and like in sync. These are the challenges I think like a lot of systems at scale would face.
Okay, sounds good. Now, let's even drill down more into the tools processes. So, did you see any particular set of tools or parts of the pipeline that you see the current tools fail you the most? That you think that they did not really give you what you're looking for? They could make your life easier, but because of those challenges, and now there are so many moving parts, there's so many challenges, many decisions that you have to make almost every day. which one of those tools that you felt, or or I would say area that you felt that that you feel that it failed you uh, uh, to achieve your goals, to have the proper velocity.
Okay. I'll give you a direct answer and an indirect answer, but let me start with the obvious direct answer, which is a lot of the tools that exist today, like cost reporting tools, like Cost Explorer and all of these things. Sometimes they give you recommendations, sometimes they give you some advice. But at the end of the day, you get like maybe some projections, right? But they do not understand your business needs. They don't understand what's happening. They just give you dumb, or I would say like dumb projections, almost like linear regression. Like, not that this is dumb, but like it's whatever is available to them. So one of the examples I would say is that maybe one of the public clouds would have a cost reporting tool and shows you like you can actually do a lot of great things on them. You can slice and dice by project and by service and understand like the cost of like how everything is going to be. But they don't tell you like, oh, by the way, there's this like new project that you're working on, new service you're going to deploy in like a few months or a few weeks, which is going to require more memory and maybe more CPU. Actually, might require something that you did not account for, like outside network bandwidth, right? That is not inside the data center that you're in. So that's going to cost you like 10x, like what you're used to or what you projected. So this kind of opaque, like or lacking reports are, I wouldn't say like not helping much. They're helping to some extent, but a lot of times you sit down and you do your own projections, and they don't translate exactly to there's some hidden costs that you did not account for, and that could be remedied, of course, by other means. Like you can hire somebody who's like very experienced, like coming up with this like financial model for software. But honestly, at the end of the day, one of the hardest things about like cost estimates is you don't understand, like especially for a startup, like how many people are going to use the product, right? Mm-hmm. So a lot of scenarios you have to play, and there are a lot of optionalities as well, like a lot of alternatives. You can go with like reserved instances or spot instances, or you can do some like bidding on them spot, or basically figure out like which one of these options will be best for your upcoming like feature of use. It's hard because you don't know like how this product is going to be used. The indirect answer, it has to do more with the kind of latent events that or latent factors that you don't account for, besides the things I just mentioned. And, you have observed factors, so you understand, for example, like how your system is using CPU and memory. But then a latent factor would be something like, I don't know, you have a marketing campaign and somebody like, just basically from the marketing department sends a mass email to all of your customers, and suddenly you have like the floodgates, open on your front end. And it happened before. I talk about it in the book actually with Xbox. I think it's Xbox 360 and Amazon.com broke that day. Like it went down because of it's just huge amount. Like you just did not anticipate the workload. You did not anticipate like how much traffic you're going to be getting, that spike of traffic. So these like outside signals that you have to capture into like your estimation of software and deployment and maintainability of the system are very hard to like, capture, and they cause other cascading effects. Since that incident that happened with, I think it was 2006, with Amazon.com, they started having more of like, not just circuit breakers, but they also had like, I think buckheads. So basically they have like isolated islands of servers just for that offer. So when you're doing like a referral for an offer, it just goes to this like set the clusters basically that are supposed to like handle that offer. And if they fold, like, if they break down, if they go offline because of the basically DDoS attack that happened because of marketing, they're isolated. So there's like isolation of infrastructure, isolation of concerns as well. So these are the kind of lessons you learn. but you can actually apply the whole like latent factors thing to like even within software. I can't think of a good example right now, but imagine all of the things that go into like making software, the processes, the coordination between multiple teams, and then things that you do not account for that could be super important at the time where you discover the issue. And there's a ton of stories that many books, not just mine, talk about, like when some people like depend on another system. And one of the biggest like maybe bugs that are known, like when two teams talk about like different units of measurement, and like it ends up in like some probe like going astray, or like, I think that was a NASA specific bug where the system is talking in metric and the other one in imperial units, and these things need to be figured out, just not just like human errors, but also like protocol errors and other errors that you have to account for. So a lot of testing is required, a lot of different layers of in-depth testing, and at each layer you can account for. But honestly, when it becomes like a deployment thing and you have a lot of levers and a lot of control, things could go really awry. And I would say like I think when things go awry or things happen like because like there's so much input going in, this is where AI actually kind of shines. It's all about decision making at the end of the day. Like, should I up the capacity for this kind of service or not? Should I go and like react to this like spike in traffic, or is it gonna wind down? Should I go and over provision? So I think this is actually the question that started this conversation, which is basically, hey, like I can spend a lot of money over provision and I'll never, worry about like capacity issues, or I'll never worry about like, spikes. But at the end of the day, I'm draining my money and runway. Basically, I'm paying a lot of cost for something I may or might actually never use, or may, never get like, maybe I'm just, my consumption is like 20%, or my utilization of the system is 20%. How would you know? So there's some like, heads up display that you need, like a command center where you see like everything. So the first thing is like transparency or observability. You need to see first before you make decisions. But then you can make decisions in a manual way, depending on, you're relying on human expertise. And this is where you capture observable factors, but then you miss on the latent factors. The nice thing about AI is it can do this very fast. It can do it because it has seen a lot of these scenarios happen before, but it can also discover latent factors that you may not connected the dots to reach. So there might be like, here's an example. So this has nothing to do with marketing. Like it might be a latent factor. It has to do with the interaction between multiple factors in your deployment or in your own, even like day-to-day operations. So the constant thing in computing is actually change. We always have changes, whether it's code sharing because of new changes and requirements, or you're reacting to a bug or a feature request. But there are also changes because of real world physics. Hardware fails. People have to go and change hard disks. I can't say exact numbers, but like we used to change, a lot more disks than you would think at Microsoft. When you have like hundreds of thousands of machines, it's just a mind-blowing failure rate because, these things rotate, they're magnets and they're, readers and whatnot. They actually like had a decent failure rate. And even if you have like a SSD, which you also used to have at that time at scale, they have an annual failure rate. So everything fails, motherboards, network cards.
Sometimes it's really hard to predict that.
Right.
No matter how good your model is, I faced some experience in EC2 where we're having lots of hard drive failure in a particular data center in a group of racks, and we didn't know why. I mean, it was something. It took us a really long time to to really pin it to a specific factors impacting this, but it's really a challenging task to build a model for these. But
We've
yeah,
seen it all. Yeah, we've seen actually failures where the disk does not rotate enough, or doesn't rotate like certain areas do not get read. You actually have like stale disks that's just sitting there without any activity. The zeros and ones will start getting close to each other and they flip.
Yep.
A lot of failures are just bizarre. So you would have to be ready for this kind of like, bizarre failures. But the idea of like, observable failures is like you can see them and you can have like maybe an event log that tells you what happened. But what if there's a failure that happens because of like an interaction between multiple failures, and then you reach that state without knowing? You don't know what to do. You only can work with the first order, let's call them first order observable factors. But then there are unique situations or scenarios that would happen where this cascaded failure is only the result of multiple failures, and solving the individual ones would not solve a problem. Actually, it might make it worse, right? So like one of the things that we worked on at Microsoft was that remedy system, right? So it basically observes the state of the world, and you have a desired state, and it tries to match this all the time. And one of the things we will try is like a policy, like multiple actions in escalation order. Okay, the software, and basically you're as a developer of the system and working with like ops or SRE, you would come up with this like remedy policy, and you would say, okay, first action to choose is like maybe restart the service. Okay, second action, if this doesn't work 3 times, try like rebooting the machine or re-imaging from scratch and stuff like that. So all these things are just, and you can escalate to a human and whatnot. But it's not usually like one series of events that lead to that. You have to actually read so many things and triangulate the error. But the idea sometimes you reach a kind of latent failure mode, or you miss on that latent factor where you do an action that works for one of the observable factors, but it leads maybe to like, loss of availability because you had like restarted 20% and then you waited, because you always have a kind of a limit on how many you can restart. So let's say you restarted 20% and for some reason the package that you were running or the software that when it restarted, it loaded the wrong dynamic content and it just failed. So it read from a database bad value and now it's just like not gonna reboot. And then, somebody can think of that as a single observable failure, but the reality is like there are multiple things that went wrong. Somebody changed a database entry and it led to this other thing. But the idea is like if you have higher observability, which is harder to do with humans, and you cannot actually like fit all this in your brain. But imagine if the AI can read the logs, not just the event log that you were looking for, but it can read everything in real time and uses this as features, whether it's like logs of application, logs of the operating system, past history, and then it can come up with the optimal policy for the situation, right? Because the nice thing about these kind of problems is they're what we call like compressible, or there are a lot of redundancy in them. So the idea of redundancy is basically their patterns. So the training data and the data in the real world, or the test time data, have some similar patterns, similar distributions, and there are a lot of factors that go into like this decision making. So whenever you have this like highly complex decision making that requires a lot of information to be fit into a system, humans do not do a great job at doing this, but machines can. And the nice thing about it is that you can pick on a lot of signals, not just the immediate signals, but you can also do a lot of like latent calculations or latent factor, taking into consideration when you're making such a decision. So I tried to do something a little bit similar when I was at Microsoft, which is using the Markov decision processes to come up with the proper or the optimal policy on the fly, instead of using your expertise as a human to come up with this process or policy of actions to like, hey, go reboot twice, or like, do this once and like try this 3 times. Use the history, use the observable factors, and then come up with like latent factors, which will allow you to like calculate states, where each state is basically like, represent like maybe the software after a failure or software after a success. And then you have arcs, or basically edges with state probability, state transition probability on each one. And you take the optimal path to like, where you want to be based on the kind of calculation you made, which is the MTP or the Markov decision processes. Now, just quickly on that, exact technique or method is not maybe the best one. There are a lot of things that have happened since then. And I think like deep learning and so on has changed the way we do things. The nice thing about like deep learning is you don't have to worry about the representation yourself, that you don't have to worry about the feature engineering. You don't have to say, well, go and like calculate these features with these values. Like, oh, how many failures did you get? Oh, how many lines of log did include this word? Now we can literally just feed, theoretically, you can feed the deep learning system the log lines, and it can understand what happened to the system. It can actually tell you, like, in a kind of latent space, like, a representation of the system that humans cannot easily reach. So to sum it up, I think whenever the calculation is required, that includes a lot of input or a lot of signals that you have to consider. Some are clear first order, and some maybe second, third order, or higher kind of order of latent kind of variables or factors, but also the speed of reaction. If you want to do something predictive or you want to do something reactive in a second or sub-second, AI will shine in that situation.
Sounds great. I love that, and that's also an area that I personally worked on at AWS, and we face the same problems. But now that maybe brings us to an interesting angle to that. You and I, we worked at big companies, and we also worked at startups. And you've been mentioning Microsoft as one of those, companies that had those problems, serious problems that they wanted to solve it, and you try to solve it this way. Now, what is the threshold? When do you
Yeah.
think that companies should consider this approach? Or teams should consider that approach? Is this something for big companies or for systems of a certain nature, certain size, or it should be applied everywhere? And what is basically the value that others could get? Or is it just maybe, just in those very few major cloud providers that would face that problem and that's it? Maybe it's not needed. Did you face something similar to that at Voicea or any other smaller projects?
Yeah. I think these problems happen to every single company, regardless of the scale of like the number of employees or the kind of, whatever you use to qualify what a big company is. So I think one of the things you could use today is like the AI or whatever solution, doesn't have to be AI, by the way, whatever solution allows you to manage the cloud in a clever way to save you time and money. And of course, provide you with the availability, security, and all the things we talked about earlier, all the principles and the challenges we face, you should use right away. I don't think there's a question about it, because it's either augmenting your workforce or you're taking, time and effort and money to put into like hiring folks who can manage this for you. The idea is like if you can get AI to assist you or software assistants to do this for you from day one, at least, if you're not using your runway to actually do this, I would say it's advisable to do from the beginning. So from early days, we had like all of these like cost advisors setups. We understand. Remember, we talked about like observability. You have to understand how much you're spending first. You have to understand where things are going. You have to understand how you're deploying. You have to like figure out, okay, what are the things that you're unhappy with? So like I'm unhappy with manual deployment, but I know I'm doing it. It's a bit different when you're unhappy about it versus you don't know that it's bad. So I'm okay with it, being there as a known issue and a kind of tech debt versus like assuming that this is how it should be done.
Got it. So you recommend that in general AI should be used early on, even if my scale is not as big as, forget about Microsoft and AWS.
Yeah.
Those are different world. But I usually get this argument. Look, I'm still a startup. I care more about moving fast. AI is not part of my, AI for infrastructure, AI for optimization, whatever the problem that I would like to tackle within my software development lifecycle is not a differentiator factor for me at this point. Why would I tackle it at the beginning? When should I tackle it? What is your point of view? Even, maybe you can share your experience or your thoughts. You definitely went through that. You the company you started with three, your two other co-founders, Omar and Ahmed, and then you guys grew to how many before the acquisition?
Right, right. So that's a good question, and we also have David, so four of us. But the idea of like even the growth of the team, you still have this like there's always like there's always more you can do, right? There's always like more folks you can hire to help you like optimize the heck out of everything. The challenge is not necessarily the size of the team; it's the growth of your customers, the growth of your footprint basically in the market, and like the load that you have to like worry about now, not just the scale of things, but also the number of services you're managing, the number of like I would say the ratio of like how many engineers per service. But the other way around, actually, how many services per engineer because you're a startup. It's usually that's the case. The idea of that workload, the distribution of work on everybody's shoulders, right? And when I say AI, the reason why I say AI, because I know that this is where the assistance is going to come from. Other systems are going to be more like human driven, right? So they're not going to tell you exactly like what you should do, but they will tell you like, here's the data, go figure out what to do, right? But what I like about an AI assistant, which is basically what Voicea was or Eva was, um, it's basically this exoskeleton or like augmented intelligence telling you like, hey, by the way, I'm working here 24/7 and like observing things for you, and like here's some recommendations. And the reason why I like the recommendations is like it puts you as the human in the driver's seat, so you make the decisions, right? So having that kind of interop, if you may, like, or kind of collaborative work between you and the AI gives you the peace of mind. So like there's nothing that's happening without your blessing, but at the same time there are things that you're not actively looking at, they're in your periphery, and they're just happening all the time, and they could be leaking money. Like you could actually, as a startup, saying like, why should I bother doing this from day one? I think it's important to build the culture from day one, training yourself and training others who are coming on board from day one, that this is important. The same way you train folks on saying, oh, hell no, like we're not going to get any PR without like, passing these gates. And if you put this from day one, it becomes reinforced in the culture, and it's not a question anymore, unless like, I'm saying like it might be a mutiny or might be like, bad implementation in the beginning. But the idea is like, it's less of a friction to introduce this process when it's already established, even if it's just a process like, that exists at a light capacity, or it's not like, in like this like very aggressive way that's taking decisions, without you like deciding what to do or giving it permissions. So there's multiple modes where you can introduce the AI or inject the AI into the process. I talk a little bit about this in the book, but from a different perspective, which is chaos engineering. So take it as a parallel, maybe maybe a good analogy, which is if you introduce chaos engineering from day one in your company, it doesn't become a problem later on to like introduce, or it doesn't become a question of like, hey, how can you do this? It's like so dangerous. Like, why would you bring this down? But if from day one, and as the system grows, it's really like a plant growing, like a seedling growing in. If you have a stake and it's growing straight, it just grows that direction, right? Versus like trying to straighten it afterwards, it becomes much, much harder. I think that's just like a cognitive, psychology kind of thing, which is you're used to this being the norm. You're used to this this is how we do things here. And if you, kind of introduce chaos engineering later on without the culture being receptive of that, it's going to fail. So one of the things I talk about is like I introduced a chaos engineering framework called Havoc Hippo to this system that was doing deployments and management of applications and whatnot deployments. And it had multiple like modes. You can turn it on just to observe. It doesn't take any actions in reality. It just takes simulated actions and tells you, by the way, I kind of like, killed this instance. Oh, by the way, I cut this network cable here. I changed the negotiation speed on this network interface, and I filled up this hard disk. And basically you start thinking, what if this happened to my application? What should I do? And you think of these failure modes. as a developer, and you start reacting to them before you actually deploy the real deal of the chaos, engineering kind of actuators.
I think based on what you mentioned, it all comes down from a business KPI. As you mentioned at the beginning, it's important to understand your business goals. The challenge here is that in the business of building a startup that is completely based off software,
Yeah.
everything is connected. Even the activities that you think that are not contributing directly to your product, they're going to impact your product. You're going to impact your business or your ability at least to execute, like how you deploy, how you manage your costs, how you manage your failures, and so on. So whenever you see, I think the key here, whenever you pinpoint one of these impacting your ability to achieve your KPI, now that should come into in the forefront. You should focus on top of on that and try to fix that problem. Now, what is your evaluation? If we let's say, what is your evaluation of the status right now of different startup companies and teams in terms of adopting AI
Mm.
for software development and operations in general? I know that we've been talking about what should happen.
Right.
What do you see right now? Do you see this is actually happening? People are having, kind of, they're now more aware of that. They're now more aware that maybe machine learning can solve that problem, or using a data science approach one way or another can solve that problem. And I think this is also one of the major changes that we see right now. More and more tools are becoming available in the cloud. More of the software development tools. The CI/CD now becoming as a SaaS, right? Even the IDEs sometimes are just on the web. They're becoming SaaS. I can collect more data, and that's also a major change that has been taking place for years now. I can I can record everything taking place from the keystrokes of our developers all the way to how every single bit is running in my production, the observability part, and just connect the dots, take all this data, and there's a decision that need to be taken with each at each one of those stages, and AI definitely can augment that and help with that. Now,
Yeah.
the examples that you mentioned are research examples, either
Hmm.
whether they are in academia or in within the industry. How, what is the percentage of those you see actually becoming a daily product, a daily kind of tools that developers would use? What is preventing us, or or what is actually slowing us down from adopting these? I see this research has been taking place for a while,
Right.
but you go and take a look at the action, the tools that are actually used, there are not that many. Why?
Yeah. So there's maybe a bigger issue or bigger question mark about the efficacy of certain AI solutions. So the way we look at machine learning or AI in general is basically uh, highly specialized in a certain task. And I would take it even a bit further, which is it's highly specialized in predicting things or doing things, given the history that it has seen, and coming up with interesting, like, conclusions, insights, recommendations, and so on, and sometimes making some interesting connections that we could not connect ourselves. So a lot of times you see research that is very promising, but it worked in language X, or it worked in, maybe like if we go for like farther away, like the AI space, generally speaking, it worked for a certain like language, as in not programming language, but like spoken language or written language, or a certain accent. Like one of the things we noticed, like speech, predominantly the research in it, English and maybe some German, but then you have like this long tail problem, right? So it just follows the money, it follows the availability of data, it follows the availability of like what you can do, like in terms of like speech researchers are doing in terms of adoption of like software, or who are buying these like services, and it just follows that. The same thing with research, by the way. It could be following some of the hot research areas, the grants are asking for these areas or something like that. So I'm not saying that this does not actually mean This does not mean that a lot of AI is actually very successfully being used today. Like you, on your Google search, or you do like any of the things that you do on Office, there's AI in all of these products. The question is like, I think the question you're asking is like, why don't we see enough of that in our software engineering tools?
Exactly.
Yeah, I would say like it is happening more and more, but it's going to require a kind of support or ecosystem upgrade in not just the way that we're providing or creating these solutions, or even like the research teams and research labs coming up with these like amazing papers and even implementations. It has to do with the business priorities, as you said, like who's going to go and buy and basically vote with their money to buy these solutions and really show the value. So a lot of things that a lot of the things that face or challenges that face AI is value attribution, right? Efficacy. Like if you're selling something that will, let's say, allow you to like take minutes in a meeting, you have to show value, and you have to show like it's actually worth the money you get put into it. So a lot of people might be skeptical of this in the beginning, but you gotta go and figure out like, this is maybe a product market fit kind of thing. So it's an activity that has very little with the engineering or the research, the technology behind it. It's about marketing and product management, understanding where are the areas where there is need and kind of meeting that need and showing the value and convincing others adopting it. But it also requires a mindset shift, right? Because it's almost like, think of the self-driving car. Okay, let's take an analogy that's a little further away from what we're doing. Why aren't self-driving cars like predominantly just driving themselves right away? But today we have, of course, certain like technological I would say challenges. Like they're not fully like level 5 or whatever level you desire to actually make it like happen. But let's assume whatever we see today, there is a challenge in cost, right? So like these systems actually cost a lot to build, whether it's the self-driving car or any data hungry system. So they usually end up like kind of like shifting the cost to the buyer. And you have also like this non-deterministic nature of AI that translates into like disappointment in certain cases. So you always have this long tail problem for most cases. And the kind of customer or the buyer and the long tail is always going to be dissatisfied. So it ends up being kind of a word of mouth problem for like AI's based systems that, oh, it did not work for me, and then people generalize, oh, hence it's not going to work for others. But the reality is like it works for others who are like the main part of the distribution, because that's where the training data came from, or like this is where the system is actually shining and doing a great job. So I think it's a shift, it's a mindset shift from deterministic systems into like AI based systems, generally speaking. You want to see something that always works, and that's really hard.
Yeah, absolutely, and I agree to that, and I think maybe we're going to get into this when we talk a bit about your experience at Voicea. But you mentioned that and you as a first factor, the ecosystem, the change in the ecosystem in general. So, what kind of technologies or parts of that ecosystem that you see that need to come first, need to happen first, so that we it basically pave the path for the AI tools to be adopted at a much higher speed. For example, in case of image recognition and voice recognition, it was the cost, the computational cost. It was really high.
Mm-hmm.
It was really
Yeah.
slow, but with the GPUs, with the multi-core processors and all of that, it becomes very, very cheap, and data is available already. And that basically opened up the door for a lot of innovation in that area. Now, if we take it to software development and operations, what is exactly where you think that we're missing, or that change in the ecosystem that would open up the door also for a lot of innovation in that space?
Yeah, you're touching on very interesting discussions. I'm just like thinking now of like the triangle we had discussing, not just with AI, but like almost every AI system. You either have a cheap fast. Actually, you pick two: cheap, fast, or accurate. So it's a triangle like where you either sacrifice cost in favor of accuracy and speed, or you just sacrifice one in favor of the other two, right? And it's usually a trade-off between these kind of opposing objectives. Now, is the cost per trillion operations going down? Absolutely, yes. We just saw like announcements from NVIDIA, the Ampere like the Ampere architecture they came up with, and how like amazingly fast it is, and like at not a fraction of price, but like very good price compared to like the previous kind of GPUs. Although I would say like there's always going to be an increase in computational requirements that goes hand in hand with this kind of increase in capability. So now researchers and engineers are going to do more on that hardware, right? So it's always like it starts with the status quo, and then there's a jump maybe in the hardware, and then the software catches up, right? And it requires more. It's like always hungry. It's always hungry for more CPU, more GPU, more whatever compute resources you give it. It will actually end up like using or abusing, sometimes out of laziness and other things, abusing it. But it's also, sometimes it's legitimately doing like really hard work to meet the other objectives like accuracy and so on. And I'm losing accuracy here like loosely. It's like it depends on the metrics that you use for your software or your machine learning system, right? So a lot of times you find like this kind of trade-off is important, and sometimes you will hit some physical limitations, like like humans actually have maybe like 3 to 5% word error rate when we are talking, because speech is a very like I would say hard to disentangle kind of signal. There are a lot of variants. There are accents like mine, and your ear might be used to like a specific way of speaking, and I have a different way of speaking, and a lot of things could go on the acoustic level. It could be like connection loss, could be like just the way that we think of words. They have different meanings. I mean, the whole idea of talking is actually, and understanding each other it's a lossy kind of way of exchanging information and kind of ideas between people and so on. So imagine computers who do not know anything, right? So if you think of NLU, and like I'll take NLU here as an example because it's really close to what we're trying to do, which is understanding. It's understanding what's happening with the system. It's understanding what's happening with software. It's translating somebody's idea. Like, a product manager came up with this idea. They worked with marketing and sales, and like the accumulation of their work came into this unstructured document that they gave a presentation about, and some engineer weeks or days later took this and like translated it into code, and of course they missed some stuff, and like somebody like double checked their work, and there were some rounds of testing, and they figured out like here's the final product. So this final product has some problems, and you still have to deploy it, and you make sure that it works with like literally maybe thousands or hundreds of thousands of other combinatorial like things that could go wrong, because the software that we build today is so complex that it uses so many libraries and so many dependencies, and just running on like an operating system introduces a lot of dependencies that you don't know a lot about. You only maybe know like a layer or two of that onion, and there's a lot of things that go wrong, and then you have like instead of one machine you have thousands or hundreds of thousands of machines. So imagine this complexity, and then you want an AI system to understand all of that, and it has nothing. It knows nothing of the world before you train it. This is the difference. You and I, we spent a lot of like many years in college, before that in school, and just in the world, and understand like how people communicate. And like when I hear somebody asking about something, I might actually go implement it the way they did. If I don't understand, I ask them for a clarification, and now I have a better understanding. Well, the AI doesn't have that option. It just gives output or outcome based on the input it sees. And you might train it in a way that asks for clarification. This is where the collaboration is important. But I don't see a lot of collaborative AI systems today. There's an interesting one that I can't remember the name now, but it's called the language game. It has a different name as well. but basically it's something that came up maybe in the 60s or 50s, where the AI, or AI, and maybe the operator, the human, is basically collaborating. Whenever the AI does not understand the concept, it asks the human to explain it in natural language. So you say to the AI, move that red chair to the end of the room. And if it understands the room, understands, like basically chair, but it does not understand red, you will say, well, what the computer will ask, or the AI will ask, what's red? And you say, well, red is this like color, and it will ask you, oh, what value of the color for like, the hexadecimal value, and you just put that, and now it understands something about the world. We're not there yet. I mean, this is a different way of doing AI. The way we've been doing AI for the past like 7 years has taken a different direction, and it basically understands from the input you give it, right? So if you think of all of these things about NLP or NLU, the transformers and the Muppetware kind of pre-trained models, the Bertology models, they're all basically ingesting a ton of text that's on the internet, books, and so on. And they're learning by seeing a lot of patterns. It's a very like highly sophisticated statistical machine. So it cannot understand, not that it matters. The word understand here is just irrelevant. It's the same, we've seen this and a lot of like amazing thinkers talk about this a lot. Chomsky and Richard Feynman, they say, well, for a computer to think or understand is just as irrelevant as for an airplane to like fly as a bird. It still flies. It takes you from point A to point B, but it doesn't flap its wings. It doesn't matter if it does, right? You just want something that gives you the thing, that the outcome of that objective that matches your expectations. Now, the difference is like some cognitive tasks require this extra layer of like scrutiny, requires some extra layer of like thinking about things that might have been missed, or subtleties in the human way of like doing things. And we're not there yet. Maybe that's one of the reasons why the AI like we use today has not been taking the world like by its horns, or like it's not as predominant as we want it to be, because it's still lacking in certain areas. But that's totally okay. I look at the AI doing a lot of great work, a lot of specialized tasks. Like it's helping me with my grammar, it's helping me with like my even designs on PowerPoint, it's helping me with like the news feed. When I read an article, it recommends similar articles. It's helping us talk right now and like take notes, and a lot of things are happening in so many domains where it's super useful. And it's also helping with like system recommendations. When you're deploying a large scale system, it tells you like, hey, by the way, we see like you've had this pattern or trend over time, and like some input that's coming to confirm that in the next week you're gonna need more capacity. Why not use that, right? So I think the ecosystem has to mature a little bit, but I think there's also this like huge expectations when I think one of the disservices that AI has been facing is the word intelligence. Mm-hmm. It's a problem. A lot of people think that this thing is just gonna be smart and do everything for me, and there are high expectations, and when they see like the results, they're met with a lot of disappointment, because they had this high expectations. If you start with some low expectations and you show them it's improved your life, the baseline is here and it's now here thanks to this system. Don't call it AI, just call it something else, but it's been saving you money, it's been saving you time. Why are you complaining, right? So I think there's some maturity that's required on the developers and the engineers who are coming up with such AI systems, to have like a safety layer, safety net, where basically either a human has to do the action, or you basically curb that disappointment in a way. So no embarrassment. You want to minimize embarrassment as much as possible. And once that is removed, then you talk about like okay, here's the value I'm bringing to the table, and I think this is how much it's going to cost you. And then we also have to work on reducing the cost of data collection, data labeling, privacy problems, concerns about ethics of AI, transparency, fairness, bias, and so on. And when these issues are, kind of addressed, then it becomes just another way of doing software. It becomes like, hey, it's a different paradigm, like functional programming, or I don't know, somebody wants to do another paradigm of like writing software. It's a data-driven way of writing software, but it has to be cheap. It has to be basically affordable and not embarrassing. I wouldn't say like deterministic and transparent it's almost impossible in a lot of cases, because the way we have developed these algorithms made it so much harder to have the same kind of like determinism and testability as like quote unquote traditional software. But this is something we've been doing for a very long time. And there's a lot of books and dissertations and discussions and painful lessons that we learned how to build software, and we came up with this like almost like a manifesto of like best practices based on collective wisdom of the community, right, of academia and industry. And they came up with these like amazing ways of doing software, whether it's OOP or like the solid principles, and like talk about like all of these like architecture like paradigms. So we figured out how to do CI/CD. We figured out how to do like scalable orchestration and so on. AI has not been in the spotlight for that long, and it's been kind of the at least like what I hear, the research departments who have been doing AI or really like the neglected ones. And since 2013 it's been just like very very like fast moving, and it's not there yet. It does not mean that it's actually going to take the same time period to actually reach the same maturity level that we have of current software systems, because we don't start from scratch. We actually have a lot of transferable knowledge we can apply on AI based systems. But it just means that it's going to take some time, some learning, some mistakes we make, and over time we're going to solve these like, again, complex unique problems. Like one of the things that you don't see today with like quote unquote like traditional software maybe is like bias, because you can test for input and you kind of guarantee that the output is going to look like that. But with an AI system, you don't know exactly what's going to happen, and that produces its own set of unique challenges. But we're going to get there.
Yeah, absolutely. And now I see it actually coming from from two angles. Number one, you need definitely the technology to be a bit
Yeah.
more mature. Some of it is around the AI itself, and based on my experience, also some of it is how you employ the AI and how you have a safe, failure, right?
Mhm.
Kind of when the AI fails to make a decision or AI fails to really grasp what is going on, how can you really disengage it in a safe way? And then, of course, there's the mindset, as you mentioned, which is um, first of all, having the right expectations, applying it in the right way, and making also the right decision, or being more kind of aware of when to use the AI generated decision versus no, I'm gonna just depend on my own kind of judgment at that particular moment. And you touched on the self driving cars. There might be some situation where you have a low risk where you can engage the autopilot, and there might be situations where the stakes are really high. You have your family with you, you're on a highway, it's really tough for you, or it's a hard decision. No, you know what, I'm going to just depend on my own judgment in that case, even if
Actually, I think of it the opposite way. I think the AI might be a better driver than I am if I have my family.
it could be it
But if
could
I want to enjoy a joyride, it's on myself. Yeah, it's just by
yeah,
myself.
it depends how
I'll
you
be
see your
manual driving.
driving and how your wife would see your driving. I would say so. That's definitely,
Yeah,
yeah. Of course, it can go both ways. Now, during your work at Vuisia, you definitely came across a lot of people arguing either with or against AI. I'm interested actually to learn from
yeah,
you. Some of the experiences, some of the arguments that you probably faced, um, or when you were trying to basically sell the AI to be a productivity tool within meetings, what kind of pushback you were getting,
yeah.
when you were trying to sell that solution to different companies and businesses? again, you're trying to sell a solution to make people more productive in their meetings. This is good, but of course, it has some sensitivities. So I'm not sure what kind of arguments that you're getting that you felt, you know what, there is a mindset thing that need to be fixed there.
Yeah, let me start by saying the customer is always right. It doesn't matter what you think as an innovator, right? Like you have to go and like figure out how to like convince folks that this is important. So you really have to be very careful about like explaining these things to people when they see the mistakes. Some mistakes are forgivable, some mistakes are not. And we try to like think of like, errors in machine learning systems in categories. And we do error analysis very, very carefully because based on a category you give the error, or categories rather, you give each error, you come up with a strategy like remedy that. So whether it's like including more context in the way you calculate the probability of the next words, or coming up with different acoustic environments, if examples of acoustic environments where you found out that the issue is not actually because of the language model or the way that you're constructing the words based on the phonetic way of representing them, but it's rather because there's noise in the environment or an accent profile that you have to capture. So it really depends on these situations and how people perceive them, and we try to like set the expectations that, by the way, this is not a perfect method of capturing transcripts, and we have to work on doing this in a, as you said, like less risky way. So you want to lower the risk factors. So maybe you can actually show the user where things could be low confidence, that there's this like low confidence area here, and we know that this might be a noisy recording, which is something that's important to communicate in the product, so that you have this I would say low expectation of the outcome based on the low signal or the bad signal you got as an input. Okay. And maybe the recommendation would be like, okay, next time you talk to the microphone, or the environment should be like less noisy, so that the machine can understand you, and so on. But the idea here is that HCI, or human computer interaction, and UX, user experience, are extremely important in AI, and I think they're kind of under valued right at the moment. But I think it's very, very important for everybody who's doing AI to not just focus on the solution in terms of like technology and data collection and like metrics and so on, that these metrics at the end of the day, you can basically take it and like publish it in a paper, but it does not really necessarily translate into real world perception and value and reception of your product. So you really want to go and figure out like, how are people using my product? So one example could be, a lot of users will come to you and say, yeah, I expected 100% accuracy. Well, that's a customer you never can satisfy, right? And others can come to you and say, actually, I don't care as much about accuracy. I just care about certain keywords when I say in the meeting, I want to be alerted of them. That's an easier problem to solve, right? So you got to figure out like, who are you talking to? Who's your customer? How are they going to be using the product? And how can you message to them? Again, remember the thing I talked about, like there's a baseline of like, you have nothing today, taking notes for you. If this solves like 80% of your problems, or gives you something that it gives you something that's not there today, that can save you time and money, would you be interested in that? So messaging is the key in these situations.
Got it. And actually, I was about to ask you about that question. Let's maybe take you already took off your engineering hat, and you're using your entrepreneur hat. What else? If I'm an entrepreneur and I would like now to really passionate about the software engineering or software development lifecycle, would like to apply the AI in one of those areas that maybe we discussed. What's your advice in general for anyone who try to tackle an area that AI could be an answer? As an entrepreneur, you mentioned one or two factors, or one or two things that are really important: the messaging, setting the expectations with this message, and of course finding the ideal customer for you, which is part of the PMF or product market fit that you need to look for as you kickstart your startup or your efforts towards that direction. What else that comes to your mind that I should consider?
There are too many actually. So I think one of the recent things that I read that I would highly recommend to any entrepreneur, whether they're technical or not, going to dabble with any AI or AI adjacent startup or solution. It doesn't matter if it's a startup actually, or a project within a big company, or whatever has AI in it. They should read a recent article came out in August, I think, called Taming the Tail. It's from Andreessen Horowitz. It's about how to understand these challenges and like the things that might work for a certain sub segment of your market are not going to scale automatically to the rest. There's an economic kind of price you have to pay, like a lot of complication that will happen with, like, do you have to build multiple systems, one tackling each of these subsegments, or do you have to build one system that will actually be suboptimal for most of them, but like helping the the ones that are in the main section of the distribution, but not the tail? What if the tail is thick? It's actually, if you sum up the area under the tail, it's like 50% or more. It's a very bad position to be in. So you want to figure out first, why are you doing what you're doing, or why are you embarking on that venture? And I think there's also something maybe I'm not sure that a lot of people think about. Maybe a lot of people do, but I would say, like, I personally would think about, which is the ikigai kind of philosophy. Am I adding something good for the world? And I'm talking about, like adding value that is going to help others, or improve the life of others, or save people money, save people time. So if you start with the why, the how and other things are going to come after that, but it gives you this like fuel to think about like the rest of the story. So maybe this is not AI specific, but I think especially with AI, the reason why I emphasize that, it's because startups and ventures by design, without adding the AI complexity, are risky. We all know this, right? So the idea of adding AI, which is already inherently risky, to this makes it doubly risky. And there's a lot of things that could go wrong, and basically your project and venture could fail because of either of these categories of issues and complexities. So the non-determinism characteristic, or the quality of being like harder to predict than kind of classical traditional like software systems, and the experimentational nature of developing AI systems add a lot of stress as well. You don't know what the outcome is going to be for your customers. If you're building an app that basically, like, let's say, what's the simplest example? A calculator app, right? Everybody will more or less get the same experience because you don't have that many variants. Like, yeah, somebody might run into an issue because they decided to actually do, like, what's the square root of -1? But like what's going to happen on your calculator app, because you can just input the same, input, and you get the same behavior that happened to them. But for AI, it's really hard. Like, if you're, let's say, doing something with media, well, you're going to need exactly to replicate the input that this person, gave the system. And what if you don't have that luxury, right? So a lot of things could go wrong, and you don't have a way to actually understand how it's going to be perceived by others. So be, kind of ready emotionally and psychologically for this kind of like journey where you're not in control of the outcome, not just, the outcome of a startup because of the product market fit, but the outcome even on a single user's experience, and multiply that by the number of users you can have, and understanding that that even developing that software is going to be a process where you are not guaranteed that the more time and money you spend, that you're going to get something out. In like traditional software kind of processes, you can more or less estimate when you're going to meet something. Like, of course, there's always integration problems and whatnot, but for the most part, you have a handle. You can actually say with a certain like high level of confidence that, well, my team is going to develop the system. It usually takes like 3 weeks, give or take, some margin of error. We're going to finish and like deliver this on that date, on that sprint, right? You can't say that with AI. Like, you might train a system after 3 weeks and you figure out, oh yeah, it's not meeting the criteria I decided, even though it could be meeting the criteria in the lab environment, right? Offline evaluation. So it could be, let's say it's matching everything you wanted, you deploy it, but then you do an A/B test and you figure out, yeah, users are not interacting as I expected with this. This happens a lot with like our systems at LinkedIn. We have offline evaluation, and this is the first like line of testing that you do, and you figure out, oh yeah, this recommendation system looks very promising. We see an offline lift in metrics by X%. And the way you actually test that hypothesis, because even though the offline data looks like, the data set you collected offline is close enough, it's a good proxy of what you expect users will behave, because it's actually a capture of user behavior the month prior or maybe 2 months prior. You put this into like the real production system, and because of whatever is happening, whether it's interactive, latent things we talked about, like another system came in and maybe it's capturing like the user's time and engagement more than the news feed, or there's a UI change where the novelty effect is capturing like messages is taking more time, or even like another competitor came out at the time where you're launching this product. So many things that go wrong, including your own assumptions about the underlying factors that came about to actually produce that model that worked nicely offline, because it's still a proxy of what like distribution of data that you see online or in real time in the real world. It's a concept drift. So there's a huge difference as the data becomes more and more stale that you might not have accounted for. And then the real test is like what customers tell you, and they vote with their own actions. They vote with their own usage. They vote with their own clicks and likes and comments and shares. And you can see this in not just like recommendation engines, but or these kind of social media applications, but you also see it, let's say, in like an AI assistant where there is some novelty and they see like the transcripts flowing, and then over time they just say, I'm getting the transcripts, but I'm not getting the value. Or maybe because you forgot to do like something in the settings where you can configure this to capture the keywords you care about, and this is where you see the value differentiation or the value attribution. So a lot of things can go wrong, and you have to figure out, like, besides the messaging, but besides the risk tolerance that's going to be increased on so many different levels, including just building a startup that could be non-deterministic in the way you build the software, and non-deterministic in the way that people are going to see the experiences that you cannot test for, basically, unless you do some sort of like high coverage testing, statistically speaking, not just like the way we do unit testing and integration testing and so on, but high coverage as in the distribution that you're capturing, right, in test sets. And after that, you do A/B testing in real world situations where you get the feedback, and you have to have high iterative systems where you can go and like move things faster. So it's maybe a balance between AI and rule-based systems, because you cannot actually change the AI models at the high speed that you can fix things in a rule-based system. So imagine, like, and we did this a lot actually at Voicea, where somebody had a kind of a bug and we fix it within 24 hours. And that's a great experience to have as a customer, right? So you want to see something fixed right away. And one of the things you would face basically is that where you find that balancing act, where you have the safety layer. We talked about like really like taming or reining in the AI with the safety layer, where you don't do embarrassing things in terms of like, AI showing you something. For example, like, transcripts. If it made a mistake and it was a curse word mistakenly transcribed, you don't want to show the curse word. You don't want to show stars or something like, like that. And we had that. These are real issues that you have to worry about. And there's actually a nice article about like how to build a safety net around your AI from the chief decision officer of Google. And I read this like recently, like a couple of weeks ago, but it's something that we've already deployed in different areas of our products that we see, because we realize that this is going to be embarrassing if it comes out like that, and we have to like rein in or tame that AI. We had the same thing also at like LinkedIn, where we can infuse some of the decision making that we do as humans to overrule some of the things that AI might show you. So one of the things like recommendations engine can do is like, yeah, like Geish and Ahmed are very close. So I'm just gonna show everything on the newsfeed from Ahmed on Geish's newsfeed.
Yeah.
It's a good optimal strategy, but it's not really something that you want to get as you want to burst that filter bubble and actually show diversity and so on. So these are very high like level things, but I think if we drill deeper, we can spend like hours and hours and hours on challenges of AI economics, AI reception, AI messaging, human computer interaction, and like UX of AI solutions. But it's a very interesting field, and I think the main thing is to have the mindset of everybody on board, or almost everybody on board, the founding team, to be aware of these challenges and just be ready with some strategy instead of being kind of be facing the music when it actually happens, but like being a step ahead of the kind of challenges, or understanding these changes are coming. As I told you before, I'd rather know I have a non-issue than be like blissfully ignorant of like, oh, everything is hunky-dory and I think that the world is fine and it's rosy, and in reality like it's on fire. I'd rather know it's on fire and I'm gonna do something about it, maybe the next sprint or the next iteration. But I think the unknowns are a problem, and I think combating that is the first step.
Yeah, I love that. I love what you mentioned about it, and I personally faced a lot of these. The messaging, of course, very important.
Mm.
Balancing the AI with some of the hard rules or some of the rule
Mm.
based kind of engines, because that's, as you said, you need to move really quick. AI is not yet there, or that's the nature of that space in general. You need a lots of data, you need lots of training and lots of trial and error before you get the right, quote unquote, the right model. So that's really important, and I think a lot of entrepreneurs may feel sometimes guilty about that. I personally had this experience at a certain point. I was telling myself, look, we're an AI company. Why we're not using AI? We should use more AI. Even though sometimes when you go to some of the problems or some aspects of the problem that we're trying to fix or solve, it could be done by hard rules, at least initially, until you reach to a level of enough data, the right number of customers or the right customer and so on, because you're going to pivot a lot. You're going to change a lot your messaging or the features. So starting with heavy weight kind of system and depending a lot on advanced AI at the beginning might slow you down. And as you said,
Yeah.
the nature of the space is highly risky. Of building a startup, there's a high probability of failing. What you want to do, you want to be in the game as long as you can and iterate as many times as you can during that short period of time that you have for you as an entrepreneur on that gig. Well, cool. Well, thank you very much, Geish. I learned a lot. I'm going to actually go back to the recording and take some notes, and I'm going to use some of these. I love how especially you framed the lost part, and obviously, there is an agreement. If I take a look at the other interviews, the previous interviews that I had, also with engineers and leaders in that space, whenever there is um, high amount of data, there is a quick decision making that need to be done where the humans cannot really
Mm.
grasp either in speed or grasp the huge amount of data that they need to process in such a short period of time. AI definitely shines there. And I think in software, as you also mentioned, tools are changing. More data is now available, and I think this is one of the one of the catalysts, one of the factors that are going eventually lead us into AI kind of augmented or driven software development and operations, where we had some promising tools in the market right now, and there is a lot of research, but it's gonna take a bit of a time. And as you
Yeah.
said, so the mindset is really important, or setting the right expectations is part of it. What do I expect? Because as you said, the word intelligence could be deceiving. It has a lot of meanings to many people, and if we do not really set the right expectations, people eventually can just give up and say, you know what, it's not going to give us what we want. But it actually going to improve a lot. And as you said, sometimes we just have a very simple formula. Look, you did not have this. Now I have something. Yes, it's not perfect, but you didn't have it before, yesterday. Now at least I'm saving you some time or money, or some effort that would make you, faster or better at some other things like Grammarly, like what we see also tried and still doing, from within Cisco at this point. Well, great. Thank you again, Geish, for all the inputs. I really appreciate the time. Thank you for taking some of your weekend. Just for everyone to know, it's Sunday night here now, and Geish, generously decided to have this time with us and discuss some of his experiences. Thank you very much.
It was my pleasure. Thank you.
Thanks. Bye.
Bye.
Hi everyone, thank you very much for watching. Appreciate your time. Wanted to share with you something quick. I'm working on an exciting new book about the use of the AI in software development and operations, which is going to come out by the end of the year. To make the book as powerful as we can, I'm interviewing industry experts to share their stories, give their experiences and advice. If you would like your story to be included in the book, please click on the link below. You can also sign up to get regular updates and an early version of the book when it's published. Thank you again for watching. I'll see you again in a new episode of Looking Ahead. If you like what you saw, please click on like and subscribe to the channel. I'll see you sometime soon.